Good afternoon, everyone. This is K. Hasini from Group 330 here to explain about the Joyverse project. Joyverse is an AI-powered real-time emotion analysis system designed to enhance the learning experiences of the dyslexic children. Let us take a deep dive into this project. So what exactly is Joyverse? It's an AI-powered system that tracks facial expressions in real time while dyslexic children play their educational games. Based on their emotions, the system adjusts difficult elements of the games like difficulty, themes, and rewards, all under the supervision of the therapist. The goal here is to make sure that the learning is more engaging and personalized to each child's need. We know that the dyslexic children often struggle with traditional learning methods, and most existing educational games don't adapt based on how the child is feeling. That means that if they are frustrated or losing focus, the game just keeps going the same way, which isn't very effective. Therapists, on the other hand, need better tools to track the children's engagement and emotional responses. Joyverse fills this gap by creating a system that adjusts the gameplay in real time while providing the therapist with the valuable insights. So our solution to this problem is the Joyverse. Joyverse is a smart AI-powered system that personalizes educational games by analyzing the expressions and the sentiment. It's built with the transformer models and MERN stack, meaning that it can adjust the game elements dynamically as the child plays. And since the therapist plays a key role, the system ensures that these adaptations follow best practices for adaptive learning. Coming to the dataset and the pre-processing, one of the biggest challenges in emotion recognition is having a good dataset. Since existing dataset of children emotions weren't accurate enough, we took a collaborative approach. Multiple teams contributed 50 images per emotion, helping us build a more reliable dataset. We also used face mesh to extract 468 facial landmarks per image. These landmarks become input features which we label each image with emotions such as happy, sad, or frustrated. Pre-processing is the key here. We clean up any incorrect data, verify that the facial expressions match the labeled emotion, and normalize everything to make sure that it's consistent for the training. Coming to the users and their interaction with Joyverse, Joyverse serves two main user groups, dyslexic children and therapists. For the kids, it provides a personalized and adaptive gaming experience. The system tracks their facial expression and uses the data to tweak the game in real time, whether that means making it easier, harder, or more fun. For therapists, Joyverse is a powerful tool that offers AI-driven insights into a child's emotional state while learning. Therapist chooses the themes for each children's game, and in return, they get the emotional analysis report which help them plan better interventions. It's a win-win for both groups. Now, let us break down the architecture diagram of this project. The first is the front-end components. This is where the user interacts with the system. We are using React to create a smooth and engaging experience for the kids playing the game. The game also integrates the facial mesh to track the facial expression in the real time. We also use the transformer model. This is the core of our emotion detection system. It processes facial expression data and classifies emotions such as happiness, frustration, and excitement. Coming to the API endpoints, API acts like a middleman, making sure that the data flows between the front end and back end and AI model smoothly. Coming to the Mongo schema and database tier, we store user data and emotion analysis results using MongoDB, which helps keep track of data of how kids are responding to the elements of the different games. Coming to the backend and middleware, we are using the Node.js and Express. The backend is built on Node.js and Express, handling all logic and communication between different parts of the system. We are also using Flask API for the model server. Our AI model runs on Flask where it processes images and predicts the emotions in real time. Coming to the cloud deployment, since we want this system to be scalable and accessible, we have designed it for the cloud employment. User interactions. Dyslexic children interact with the game and their facial expressions are analyzed in real time. Therapists interact through a dashboard that provides emotion insights, helping them make informed decisions about interventions. In short, all these components work together to create a dynamic, personalized, and learning experience that adjusts to each child's emotion in real time. This is the end of my presentation. In conclusion, Joyverse is all about making learning more engaging and effective for dyslexic children by combining AI, emotion recognition, and real-time game adaptation. Thank you and have a good day.